Aging of process equipment facilities and infrastructure are a safety concern for the chemical process industries. Prolonged exposure to various chemicals as well as extreme temperature and pressure make older process units vulnerable to disaster. Many plants now operate at rates and conditions not anticipated during construction. Aging is not necessarily related to the actual age of the facility or piece of equipment. It is about how well the facility or equipment has been operated and maintained, which requires constant vigilance by personnel. An inevitable question which comes to the mind of plant engineers is how the equipment can be kept in operation without sudden failure and how long. The answer to this question is significant not only from the cost of operation and replacement, but also from the point of view of safe operation of the plant equipment. This puts an ever-increasing pressure on operating personnel of a plant to assess the current state of health of equipment and remaining life. It also calls for failure investigation if equipment failure does happen despite all precautions. One of the most important areas that differentiates the best from the rest is asset reliability management. Indian Oil's world-class R&D center is equipped with state-of-the-art facilities to provide advanced techno-economic solutions in the domains of material failure analysis, metallurgical health assessment, non-destructive testing, etc. for equipment reliability. These advanced technologies for equipment reliability assessment have been deployed by Indian Oil to meet the requirement of its refineries, a large network of cross-country pipelines and countrywide marketing installations. A methodology to assess remaining life has been developed and is being commercially employed for assessment of critical heaters for over 2 decades. It has resulted in prolonging the life of process heaters and significant cost saving to Indian Oil against replacement of heaters. Moreover, instances of sudden and unexpected failure in heaters have reduced drastically, resulting in safe, reliable, and continuous operation of the units across Indian Oil refineries. Indian Oil R&D has developed a failure investigation methodology based on systematic approach and commercially deployed at refineries, pipeline and marketing installations for root cause assessment of failed components. This systematic approach helps not only in timely assessment of reasons of failure but also in getting more reliable results. It has helped particularly in reducing the repetition of similar failures. Fitness for Service FFS technology is a computer-based expert system that has been developed by Indian Oil R&D to assess components that suffer from crack-like defects. It has been commercially employed for FFS study of hydrogen blister damage assessment of INMAX unit components, LPG storage spheres of bottling plant, multi-layered hydrogen bullets, LPG storage spheres, etc. Reformer heaters employed for hydrogen generation in refineries are one of the most critical units. They operate at a very high temperature of nearly 1000 degrees Celsius, which makes them very vulnerable to creep failure. Any unplanned interruption in their operation can interrupt the operation of other units in refinery. Therefore, the non-destructive testing (NDT) of these heater tubes on regular basis is essential. Indian Oil R&D has recently developed a NDT tool based on ultrasonic transducer UT, laser system and gyroscopic sensor. The UT sensor assesses metallurgical degradation of reformer heater tubes while the laser system measures diametrical growth. The results of all the systems are assimilated to arrive at the metallurgical health of the tubes and operability in time to come. Indian Oil strives to delight its invaluable customers with customer-centric initiatives by providing advanced techno-economic solutions in the domains of material failure analysis, metallurgical health assessment, non-destructive testing for equipment reliability,